These tech notes present two different techniques that can be used to interface the serial port to a .NET application. In this case, I am using a virtual serial port connected to the USB port. I am using C# 2010 under Windows 7 Service Pack 1. First, I want to discuss a little the testing environment. I am using an Arduino Nano compatible board called the DCC Duino. It is basically the same functionally as the Arduino Nano, except that the DCC Duino uses a CH340 chip to accomplish the interface between the USB and serial protocols. The Nano is programmed with a small sketch which basically accepts these commands that are listed here on this table, which are the asterisk or the digits 0 to 6. And it returns back a certain sequence of bytes. For example, if you send it over an asterisk, which I call the high five command, it sends back a plus sign. If I send it a 0 command, it's going to send back 1 byte. If I send it the 3 command, it's going to send back 8 bytes, and so forth. And these bytes will always be starting with 0, such as 0, 1, 2, 3, and so forth. I should mention that my application in C# actually gets back the ASCII equivalent. So for example, if the sketch sends back is 0, my application is going to read a 48. Now I'm going to bring in the device manager and a small video window here, and I am going to hook up the serial device. Let me get that. Okay. As you can see, it's just a typical Nano board, and I'm going to connect it. Now watch what happens here. And once I connect it, the device manager automatically updates, and now we have ports. So now let's have a look. Let's see what's inside that port there in that section. And as you can see, it clearly identifies it as COM5, and it also presents a little information about it, specifically the chip, the 340 chip. Okay, so now that's looking good. So I'm now going to remove these guys here, and we're going to go to the Arduino IDE to test it. The first thing we need to do, obviously, is to set the port. That's very important, otherwise there's no communication. As you can see, I only have one port here, COM5, so that's a no-brainer. However, if you had more than one port here, you have to select the one that matches the one that was listed in Device Manager when the device was hooked up. I should also mention that this device has been hooked up before, so that's why Windows recognized it immediately. Okay, now what I'm doing here is I am sending it the asterisk and the high five, and let's see if it gives back a plus sign, which it did. That's very nice. Now I'm just going to send it a 5 command, and it should bring back 31 numbers, which it does, obviously without the new line carriage return characters. So I know that my testing environment is working correctly. Now I need to have a C# application which will also do the same things that that we did here in the test environment. Okay, here I am loading up the source. I'm just going to do a quick walkthrough just to give you an idea of what is involved. It has the usual setup and loop functions. In the setup function, I am initializing the serial port, and I'm also initializing a pin to be used with an LED. I'm setting up my variables, and here's the main loop. Basically, it's a switch statement, and it interprets whatever the host sends. So here I have various options. If I am sending a command 0 through 6, it simply sets up the number of bytes that the sketch is going to send back to the host. There's really nothing complicated here. It's really straightforward. Here I am ready to send. So what I do is I turn on the LED and I send 1 byte. And then every time that this loop gets executed, I'm going to send a byte and another byte until we're done. Now here I'm checking to see whether we're done. If we are, I'm returning back to the initial state. I'm turning off the LED. Otherwise, I'm going to send over a character to the host. Now here I did have the option of using the print or the write. I chose the print to send it as a number and not just as a char. And once I send it, I increment the counter. And finally, here's a different state. Here's where it receives the asterisk. So what do? I send back a plus sign. And this basically takes care of the sketch. Next, let's have a look at what is necessary for the C# application. Alright, so let's start by looking at the user interface. This is going to be really quick. Basically, here are the steps that I took to build the user interface. I started a Windows form application, named it that, set a few properties, and added a few user interface elements. Here you can see how the finished product looks like. Right now, nothing really works. It's just a visual part of it. Next comes the code to make the user interface come to life. Basically, in the form load, I added this code so I can have various options from the drop-down list. And of course, I selected the first item so that when the user runs this program, it's almost ready to go. Next up was the button click. So in the button click, basically what I do is I disable when it starts and I re-enable when I'm done. And what I do here is I clear the items that are in the list. In this case, this is the list right here. So going back, here where supposedly the text cursor is at, this is where we're going to add more stuff later. Right now, usually what I do is I first make sure that the user interface is working correctly before I start really adding the real beef of the application. So now here we start with the serial communications, and as it says here, it is the core of the project. So what we're going to do first is that we're going to do a port scan. We're going to go through all the COM ports that are available, and we're going to try to locate where the Arduino Nano is found. And this is as simple as just sending it that high five asterisk char, and if we get back a plus sign, we're in business. So here we're going to have a closer look at how I am doing this. So here's the basic algorithm. The first thing that I do is that I send an asterisk over to the serial port. Then I wait a full second, and then I check whether I have data. Do I have data? If I do, then I come this way and I ask myself, do I have a plus sign in the data? If I do have a plus sign, then I go down this way and we have success. If there's no data, like for instance here, or if the data received is not a plus sign, then I come here to a failed state, which basically means that the Nano is not connected to the port, and I move on to the next port if available. Alright, so moving on, we now go to the first of the code. The first code that I added was two using statements so that we could use the ports, and we could also make use of the threading functionality available in C#. So I added these two statements. So you can see it's still in yellow because I haven't saved the project at that time. Next is the actual routine that checks to see whether our serial device is connected to the port. So the first thing I do is I declare a new serial port object. Now here I check whether the object is open. If the serial port is open, then I leave it alone because it's assumed that it's busy doing something else. And for us, it's not really very good news. But then again, maybe I'm checking a serial port that's connected to another device that's busy using it. Only if it's not open, then I go ahead and I open it. Before I open it, I set a read timeout so that I'm not waiting forever in case something doesn't go as well as I had hoped. Finally, after the port is open, I then send an asterisk to it, and that's about it. Next, I make use of the thread sleep method, and I sleep for 1000 milliseconds, which is basically 1 second. When it comes here, it'll be because the 1 second elapsed. So now I go and I check, do I have anything to read? And if I do, then I go ahead and I see what's up. I go ahead and I declare the buffer. Since I know that maximum is going to be 3 bytes, which actually I know it's only 1, I set it here for 3 just in case it sent an asterisk and a new line carriage return character. So now I have a buffer, 3 bytes, and I go ahead and I use the read method to get the information into the buffer. And here this just is telling where I need to start and how many bytes I'm going to read. It doesn't matter if I receive less bytes than I am trying to read, it'll just read whatever's there. But what happens here is that not only does the buffer get the data, but also here in this variable I get the number of bytes read. Here's just a conversion because I want to be able to check the message, and I need to move the bytes in the buffer into some sort of string variable. So I do this this conversion, and then I close. That's very important. You must never leave the serial port open after you've used it and you don't need it anymore. And here I return. And what I'm returning here, if you check, it is a Boolean function. So what I'm returning is a Boolean variable, and all I need to do here is check to see whether my string contains the plus sign. If it does, obviously this is going to return true, and it's going to return true. If it doesn't have the plus sign, it will return false. And here we have some else conditions just in case things don't go as well as planned. If the serial port was busy and I was not able to open it, then I just return false. I mean, that's about it. And my catch for my try. Also, here I return false, but I also will send a little message to the user to let them know that there's something weird going on. Next up is the code that goes into the button click event. Now here, this should look familiar. This is what I had already before, and actually what I added was this if statement. And so here I'm just going to do a little quick validation. I make sure that the user entered the COM port, COM number. If the user hasn't entered anything or entered a few spaces to try to trick the program, it's going to trigger here and it won't go in. So now after that, I just called my function to see with the port name and see whether the Arduino Nano hardware is connected. Or in this case, I keep mentioning Arduino and Nano, but in this case, like I mentioned before, it's a DCC Duino, and it could be a Arduino Uno, or it could be any kind of Arduino compatible hardware that's running the little sketch that we looked at the beginning of this of these notes. And here what I did is I just put a temporary message that tells me that the Arduino was found. Here I need to do something different, but for now I just want to make sure that what I have in here is working before I put in more stuff. And of course I have the else's that will give me the correct message depending what's going on. And here we have the program running. In this case, my Arduino was at COM5 when I ran this program, and it found it. I was happy about that. But the only thing that's doing right now is just testing to see where the Arduino is found. I still need all the logic that will get data inside this list. So that is what is coming up next. And we're going to have a closer look at this flowchart to explain what's going on. Notice now that there is actually two flowcharts. There's the one here and the other one here. So we're going to look at each one independently. And the thing is that with an event-driven system, you need two parts. First, you need the part that's in the main code that you're launching. Here's where you open the port and you send whatever command you're going to send, and you assume success because you really don't have any kind of evidence to show otherwise. Now there's a second procedure, and this is a separate piece of code, that this is actually the event. What the event does is when something comes in from the serial port, it automatically fires and it starts executing right here. That was a terrible arrow. The first thing I'm going to do is I'm going to get the bytes into a buffer, and I'm going to get the number of bytes read. Next, I'm going to check to see whether I have all the data in. If I do, then I'm going to close the port and I'm done with it. Here it's not that simple. Usually when I have all the data in, there's another step here. I'm going to change color here. I'm going to put this down here, and it's more code because that I'm processing the data that I have, and I know that I now have all of it. If in case the data is not in, I still declare success because, well, maybe the rest of the data is coming in the second batch. The way this thing works is as the serial port receives data, it processes whatever data is received, and then it waits for more. And this event just keeps firing as more data keeps coming in and keeps coming in. So usually there is a need to have code that will know when the relevant data is in. There are some cases where you just can't know that because the stream will be continuous. In our case, it's not. In our case, I'm going to tell it, well, I want to select a specific command which is the command I've sent here. And the command is going to tell the little Arduino sketch to send back 1 byte, or to send 8 bytes, or send 16 bytes. So I know exactly how many bytes I'm getting back, and I know when I will have all the data. I highlighted some text that recaps what I've just mentioned. This solution that I provided here, including the flowchart, is very particular to our example. Needs may vary. Like for example, here I mentioned certain requirements may not need to close the port when the data has been received. Why? Because maybe it is a continuous stream and there is no such thing as the end of data or having received all the data. So the port remains open throughout the lifetime of the application. Now, two different procedures that together form the model needed to send and receive data for the serial device. That is something very important. There always has to be that first procedure that kicks off the process, and there has to be the second procedure that handles the event when data is received. Another part that is important is this right here. I need data structures to be able to handle the incoming data and to handle the serial port in general. Like for instance, you have the serial port object itself, and you have the data structure that's going to hold the received data. Now these data structures need to be declared so that their scope is at the module class or project level. If you recall, C# has 4 different kinds of scopes. It is the block, the procedure, the model class, and the project. Of course, the two widest reaching scopes are the module class and the project, so it could be either one. In our case, we only have one form, one class form to be precise. Therefore, it doesn't make much sense to make it up at a project level, because if I declare it the module class, that will suffice for what we're doing right now. Making this object scope to be limited only within that function. Okay, this is really bad. It worked perfectly when I checked the presence of the Arduino, because I had that one function that opened the serial port, checked, and then closed it again, and that was perfectly all right. But when you're trying to do an event-driven model, a block or a procedure scope is not going to work. So now, what is next? Well, we have various steps. We have to add the declarations for the serial port object and the data structure. We have to instantiate the serial port object, and most likely we will also have to instantiate the list. We have to do something very important. We have to tell the serial port object what procedure to run when it receives data. The thing is that right now we are building the procedure that's going to receive the data, but how is the serial port object going to know that that is that procedure that needs to be run whenever data comes in? So that takes care of that. And of course, the last step that we'll need to do is to actually get the serial port process started. In our case, we do it by sending a character to the serial device, and the serial device comes back with some data. In other cases, especially when it's a continuous stream, all that might be necessary to get the serial port process started is just by opening the port. Let's summarize that just real quick. Here's the 4 steps, and this is the modification that we need to do to the program as it is right now to get it going, and to make sure that it's going to be able to receive the data that we are going to ask for. So now let's go down here, and we're going to look at some code. Of course, the first part is the declarations, and here I do mention that I do need one more declaration, which will be a variable that will hold the number of bytes that I am expecting. I'm using an integer type, which is actually a 32-bit, so that is more than enough. So here I am declaring the serial port, and I'm using the new keyword as I am with the list of bytes, a new keyword, which basically this means that it not only declares them, it also instantiates them, and they are ready to use. And here is the integer that I'm going to use to define the number of bytes that I am expecting. And here is the procedure that is going to get run every time serial data is received. Basically what I'm doing is I'm declaring a byte array called buffer, and I am declaring it with 40. Now why 40? Because I happen to know from the commands that I send to the serial device that the maximum number of bytes that I'm receiving is 32. So making it 40 is pretty sure bet that I will be covered. Usually this is not a good idea to put a fixed constant in here, but rather to use the property called read buffer size from the serial port object, and this will declare the array the size of the buffer. The default size is 4K, which is kind of huge for our purposes, so I just decided to use a very small number here. Here is the instruction that actually reads the serial port, and it tells you how many bytes were read. In the other procedure or function that I have, I am not sure if there's any bytes to be read, so this might be 0. But here in this event, I know I'm going to get something greater than 0 because the event itself was run because something was received. So I'm almost guaranteed that there's something there. The next thing that I do is I resize the buffer to the number of bytes read. This is basically an array resizer. So I won't have anything extra. If I'm receiving maybe 8 bytes, it's no point having a 40 byte array, especially when I decide to move the contents of the buffer, which if you'll notice it's a local, the scope is at the procedure level. So I move it to a data structure that is at the module class level. And what that does is it basically guarantees that when this procedure exits, I may lose the information in the buffer, but it will be safely kept here. The thing is that if I leave this at 40 and I receive 8 bytes, it's going to copy all 40 bytes into the list, which is basically a waste. And this is actually dangerous if you have a continuous stream where you may receive less bytes than the size of the buffer. So you always have to trim the buffer to make sure that whatever you get in the list is really what came over the wire, so to speak. Here's where I simply test to see whether I have received all the bytes. I compare it against the variable that we just declared to hold the number of bytes expected. And at this time I'm just closing the port because I know I am done. Here I will need to do more work, but I will add that later on. We now have the code necessary to initiate the serial port transaction, and we have the code that will receive data. Now we just need to add the right code in the application to make use of all this new functionality. So this is what we're going to do next, including setting the bytes to receive variable. If you notice from the user interface, the way to select the number of bytes that we're going to get back is by selecting the command. If you recall at the beginning, if I select command 0, I'm going to get back 1 byte. If I select command 1, I'm going to get back 2 bytes, 4 bytes, 8 bytes, and so forth. So we're going to modify the drop down, the combo list is selected index changed event. And luckily it's just one line. All I need to do is grab the number of bytes that I'm expected depending on the command that was selected. Now here it's pretty easy because if the command is 0, it's 1 byte. If the command is 1, it's 2 bytes. So basically it's actually raising the command to a power of 2, and that's how many bytes I'm getting back. So once I have that, I don't need to set this again unless I decide to change the command that I'm sending it. Alright, so now we go back to the form load. And we go ahead and we instantiate the serial port object, and of course we have to add the name of the procedure that will be receiving the data. In our case it was serial port data rx event, so you have to be very careful because the serial port object has its own event list, which is called data received, and we're going to append to it, so that the reason for the plus equal sign. And of course we're going to create the new event handler given the name of the procedure. So here that's one more step done, but as I mentioned here, we're not done yet. There is one more step that we need to take, and this is sending the command to the serial device. The code needs to be added to the button click event. I'll comment the statement that displays the message and add the code there, since that's since that message it was just temporary. So we're going to drop down to image 15, and here we go. Is this image 15? Yes, it is. Alright, so here we had the message which I commented out, and I've simply added some new code. The first thing I'm going to do is I'm going to set the port name given the port name that the user typed in, which, as it mentions here, is the COM designator. And then I go ahead and I open it. At this time I assume that the COM designator is correct. And once this is open, I go ahead and I write the command. Now here's an interesting thing. You might say, well, how am I going to know if this is the correct one? And the thing is that when the user clicked the button, it already checked. It checked here to see whether this the designator was correct, and only if it's correct will this be true and it will fall here. So I am pretty safe of using the same designator that was here also here, because if execution is here, it means that this is correct. So once it's open, then I go ahead and I grab the command from the text that's inside the selected item in the drop-down list, and I send it, and that's it. No more need for anything else. I don't need to wait. I just need to finish up here this procedure and let the program do whatever it has. Nothing should happen, of course. We should be receiving the bytes, but we are not doing anything with them. To verify that the program is working, to go to the receive event and put a breakpoint on the line that reads the data. So we're going to go here and we're going to set it int bytes to read the serial port, read buffer. So this is looking good. Before we move on, I just want to make note of something really quick. I'm going to go back to where I instantiate the serial port object right here. This is not really necessary. If I go further back to the declarations, let's locate these real quick right here. Using the new keyword, I am instantiating it. So actually doing this and doing this is redundant. I went ahead and actually commented this line out, and everything worked perfectly. Okay, so let's give this a run and see how it looks. I'm going to go to the development environment. Here I already set the breakpoint where the image indicated, and I'm just going to go ahead and run it. And I'm going to move the little window inside the view, and I'm going to type in COM5. And I'm going to select that we read 4 bytes. That's good enough. So I go ahead and I click read, and it stops where it should. So here I'm going to just a single step it, and let's see how many bytes it read. Oh yeah, it read 4 bytes. Yay! So now let's look at the buffer and just click the plus sign, and there it is, 48, 49, 50, 51. Those are the 4 bytes that we are expecting. And right now I'm just going to let it run through, and there's the 4 bytes. Note is that I ran the fully completed program in the development environment. So as you saw, the bytes that were coming in were successfully placed in the list. If you were to run the program now following the documentation, that's not going to happen, because we still don't have the code to move the bytes from the receive buffer, which was the byte array and the byte list, over to the list that's on screen. Moving on, as you can see, I have here more text that basically describes what we did real quick. F10 to move to the next statement, and here you have a graphical representation of what the list looks like. In the case of this example, I chose to receive 8 bytes, so it has a count of 8, and it starts at 48 and it goes to 55. Which leads us to the next step, to actually move the bytes from the list over to the on-screen list box. As you can see here, I have documented that we'll be using the items add method. This is pretty typical, and here is a snippet of code which basically adds to the code inside the if statement whenever it determines that it has finished receiving all the bytes. Before we didn't have this, we just went straight to close the port, but now we have a little logic here. And basically it's very simple. It just uses a for each loop to traverse the list, and it grabs each item in the list and it adds items to the list box. Now the code is almost complete and we can run it. However, when we get to the part where the list of items is being transferred to the list box on screen, we're going to get this message here. And it's very important to actually understand this. Here it says a cross-thread operation. The thing is that when the application is waiting for something to be received from the serial port, and it is received, instead of making just a blatant jump to the code to execute the event, it starts a new thread and it executes that event in the new thread. However, threads cannot just be updating user interface elements just like that. Now here I should also point out that if, for example, the application that you needs to process the bytes or the information, the data that's coming in from the serial port in such a way that it does not affect the user interface, which basically means you do not display anything, you really don't need to be thread safe. In my case here, I am actually displaying the bytes that are coming in from the serial port, and of course there are situations where this is necessary. So I need you to bear with me a little bit longer to figure out how we can solve this by making this operation here thread safe. To make this work, we're going to employ something that is called a delegate. A delegate can be seen as a description or a definition of a function that's going to be passed as a parameter. Usually when we talk about parameters, we talk about maybe integers, lists, arrays, many other types. But the thing is that with delegates, you can actually pass a function name as a parameter. Now here is the declaration of the delegate, and here I'm doing a few things. I'm declaring it void, which means that the function that I'm going to pass as a parameter does not return anything, and I'm also describing its type. In this case, it's the update UI elements, which basically means that the function that I'm going to pass is going to do something with the user interface. And finally, I describe the parameter that's going to be passed to it. In this case, I want to pass the list of bytes that have been received. Therefore, here in the type I say a list of bytes, and then I provide a name for the parameter. Now we have to get the code to actually do it. So here we're going to put together a small procedure which I call just GUI update list box, and the only thing that it's going to do is going to accept a list of bytes. It's going to grab the bytes in the list, and it's going to use the now well-known items.add method. As you can see, this code here and this code that generated the error is basically the same one. The only difference is its location. So now we're going to go a little further down. As you can see, the procedure was simple enough. Yeah, there's really nothing incredible happening here. So now here's what we're going to do. We're going to modify the part inside our receive event so that when all the bytes are in, now it's going to execute this code in addition to the serial port close, of course. And what it's going to do is that it's going to ask the list box whether an invoke is required. If the invoke is not required, then this is going to go straight to this procedure, and it's going to execute the code to update the list box. Now I could have just taken this code here and simply attached it here instead of calling the list box, but I just decided to keep it a little bit modular. However, if it does require an invoke, then I'm going to grab the invoke method of the list box, and I'm going to create a new element, the update UI element, and I'm going to pass it the name of the procedure along with the parameter. If you note up here, here's the name of the procedure, and of course it accepts one parameter. So whenever I make use of this procedure, I need to give it this. And here it is. Here is the parameter, here's the name of the procedure, and I'm just creating a new object. to be able to pass it through the delegate. And now all is well. Here I explain a little bit more of what's going on. And after I have this small code in place, now we can actually run the application and it will work fine. Here I'm just going to remove the breakpoint so it won't stop, and I'm ready to run the application. So here we go, and it's going to appear a little bit off screen, but I'll move it as soon as it comes back. Okay, so there it is. I'm going to type in COM5, and I am going to select 8 bytes just to follow the documentation, and I'm going to read, and there they are. And no more problems of generating that error. Now, like for instance, if we did want to see the error in live and not just in our document, we can just go ahead and comment out some code, like for instance the if. We're going to do this here, comment this out, and just run the procedure by itself. So here we go again. I'll get the window in view, COM5. I'm just going to let it return 1 byte. I don't care. It's going to error out anyway. And here we go. Okay, so now it's taking a little bit longer than usual. And here it comes. And there you have it. You have the error that comes up if you try to do something that is not thread safe within your application. And now we go back to document. And basically that's it. I've added a few extra notes. I guess this is one of the important ones. Our example really just covered something very simple. By no means is this an all-inclusive, and there's a lot of stuff to learn inside the serial port object. And here is the Arduino code that I added to the end of the document, so that this is actually part of the text, so you can actually copy it and paste it in the Arduino development environment and create a real quick sketch that you can download, so that you can have the same software that I use to test the serial communications. And basically that's it. Thank you very much for bearing with me, and I really hope that these tech notes are of help to someone else besides myself.